Welcome back to another fun calculus video. We are going to continue the work we started yesterday with the calculus and context stuff. And actually, I only have 3 problems we're going to take a look at in this video, but with multiple parts, just to try to show you as many different things that I can ask you to do with one of these problems. I believe all 3 examples either came directly off an AP exam or were adapted from an AP exam. And these are definitely standard questions that you will see come the exam in May. I'd like you to take a moment right now. I'd like you to read through problem number 9 in the packet that you have, and maybe then just store the functions in your calculator in Y1 and Y2, and then stop. Make sure you're being good about parentheses in the denominator. Okay, so let's take a look at part A. I want to figure out how many people have entered the park by 5 p.m. The park opens at 9 a.m. and I want to know how many people have entered by 5 p.m. or t equals 17. Let's see. So I have 2 functions here. One tells us the rate that people are entering the amusement park. The other tells us the rate that people are leaving the amusement park. I don't think I care at this point about the people who are leaving. I just want to figure out how many total people have entered. I think I'm going to need to do an integral. Of what? Well, of the rate that people are entering, and that's going to give me the total number of people who have entered. When am I starting this? Well, when the park opens at 9 a.m. And I'm going to go to, well, times 17. Go to your calculator, type this in, and tell me how many people have entered the park by 5 p.m. So I think this should give you about 6,004.270. We're following normal rounding rules because this is still just an approximation anyhow. So I'm going to approximate about 6,004 people have entered the amusement park by 5 p.m. Part B. On average, how many people enter the park each hour between 1 p.m. and 10 p.m.? Well, 1 p.m. is going to be t equals 13. 10 p.m. is going to be, let's see, 12 plus 10, 22. On average, how many people enter the park per hour? So basically, I want to find the average of E of t, the average value of E of t. I would like to see if you can set up your integral and do your calculation. And decimals are going to be fine in the answer. We're just going to round to 3 places. I'm going to do the average of E of t. So 22 minus 13 times the integral from 13 to 22 of E of t dt. I'm going to go to the calculator, fn int. I'm going to integrate what I stored in y1. And I'm going to go from 13 to 22. I'm going to divide by 22 minus 13. I've got all this over here. I'm getting about 409.635 people per hour. This is people per hour. You integrate it, you get people. You divide by the time, it's now people per hour once again. About how many people entered the park each hour? About 409.635 people per hour. Yes, decimals are okay here because it's a rate. Part C. I want to create a function defined by an integral that predicts how many people are in the park at any given time. Well, here's the deal. This sort of goes back to the previous problem that we looked at the end of yesterday's video. where I wanted to figure out how many people were at the craft fair, and I took my starting number of craft people. I added, well, an integral that told me between time 1 and time 3 how many people have entered, minus the integral from time 1 to time 3 of the rate that people are leaving. That'll give me the total number of people who've entered minus the total number of people who've left. Add that to the starting amount of people and get 428. I'm going to do something similar here. My function defined by an integral h of t equals. We were told we were starting with no one in the park, so I'm not starting with anything. I'm going to take the integral from, I'm opening this park at time 9, and I want to figure out how many people are at time t, so I'm going to integrate to time t. I want to integrate the rate that people are entering. That's e. I probably shouldn't say e of t. I should probably use a different variable here so it's different than this one. I'm going to say e of x minus the rate that people are leaving, and I'm going to say L of x dx. This function, defined by an integral, we just plug in a time, we integrate from 9 to that time, and we're going to figure out how many people are in the park at any given time. Let's look at letter D. How many people are in the park at 6 p.m.? By the way, I should add a direction to this. We're going to round to the nearest whole number. Well, 6 p.m., how many hours after midnight? I think that's t equals 18. You want to find h of 18. That's why we created that function in the first place. I'm going to integrate from 9 to 18, e of x, or e of t, whatever, minus L of x dt. Go to the calculator. Integrate that. Hopefully you still have this stored in y1 and that stored in y2. Let's integrate and let's give an answer rounded to the nearest whole number. How many people are in the park at 6 o'clock p.m.? Okay, fn int y1 minus y2. I'm going to go from 9 to 18. That is not right. Hold on a minute. I must have typed something in wrong. Wonderful. Oh, good, you're not seeing my calculator, so you're not seeing what I typed in wrong. Oh, yeah, I see what I did. Wonderful. Okay, sorry. This video could have been a minute shorter if I didn't do this. I'm getting 3,185.698. We are rounding to the nearest whole number because this is just an approximation anyhow. It's not like saying there are exactly this many points to that decimal point. So we're going to round to our nearest whole number and say 3,186 people. And that will take care of that one. So the idea of creating this function defined by an integral is a pretty big deal, and we're going to use this in parts E and F right now. In part E, I want to find the value of h prime of 18 and explain what this means. Well, my h of t equals the integral from 9 to t of e of x minus L of x. And this is the function that tells us how many people are in the amusement park at any given time. If I want to find the derivative, if I want to find h prime of t, I'm going to use my second fundamental theorem of calculus that says the derivative and the integral, they cancel each other out, and you plug in your t where the x is. What's the derivative of this thing going to be? It's going to be e of t minus L of t. I want to calculate h prime of 18. According to my formula, this is e of 18 minus L of 18. Oops, sorry. Not doing a good job of keeping this on the screen today. I think you can go to the calculator and evaluate this by typing in y1 with parentheses 18 minus y2 with parentheses 18. Type it in, give me a number, and then we've got to do the interpretation, and we'll take care of this together. Just give me the number right now for e of 18 minus L of 18. Getting negative 689? So what? H of t is the number of people in the park at any given time. The derivative of the number of people in the park at any given time is the rate of change of the number of people in the park at any given time. So, what this is saying is at t equals 18, which is 6 p.m., the rate of change of the number of people in the park is negative 689. I need units. H of t is people. The derivative, people divided by the units of t, so divided by our units of time, we're going to say people per hour. And I would accept that as an answer. There's maybe a better way to talk about this, though. The derivative of the number of people in the park at 6 o'clock is negative, which means the number of people in the park is decreasing. Decreasing at what rate? At a rate of 689 people per hour. See you tomorrow. Let me write this. At t equals 18, again 6 p.m., the number of people in the park is decreasing at a rate of, I'm not going to say negative because the negative is included in the decreasing part, at a rate of 689 people per hour. Take a moment, please, and make sure all that's in your notes. Last thing we need to do. At what time does the model predict that the number of people in the park is a maximum? I want to do this over a closed interval. That means I'm looking for an absolute maximum. How do we find an absolute maximum? Well, we're going to use the candidates test. I want to find the absolute maximum of h of t. I'm going to use the candidates test. I need my critical values. I need to figure out where the derivative of h of t equals 0. Well, I previously calculated the derivative. I said the derivative was e of t minus L of t. I need to see e of t minus L of t equals 0. What makes e of t minus L of t equal 0? Or I can think about this as, where does e of t equal L of t? Those will give me the critical values, and then I'm going to have to test those along with my endpoints. Okay, so what I'm going to do is I'm going to go to the calculator, and I'm actually just going to graph those two functions that I gave you. Now we need to set a good viewing window. I'm going to make my x's go from 9 to 23 because, well, that's what I told you for the t's in the problem. As for the y's, well, let's see. These things are rates of change of the number of people. I have no clue. Maybe negative 100, negative 1,000 to positive 1,000, count by 100. I'm just guessing here. We may have to make some changes. But I'm going to graph it and find where those things are interesting. Oh, actually, this might be a decent window. Oh, nice. Oh, wow. Okay, that's kind of nice. They only intersect at one point, so I'm only going to get 1 point in addition to my endpoints. Second, calculate. I want to find the point of intersection. I'm going to click on the first curve close to where they intersect. Same on the second curve close to where they intersect. Enter for the guess. It's going to take me to about, okay, remember, since we're going to be using this and I need the final answer accurate to at least 3 places, I should give more than 3 places here. How about I just write down everything I see on the screen? T is about 15.794,815. And that's my critical value. I want to figure out, well, the absolute maximum value. I have T and I have H of T. I want to figure out how many people are in the park at the endpoints at time 9. That's easy. I actually already know that one. At time 15.794815. and then when they close at time 23. Now, I think I know when I'm going to have the most people in the park if you think logically, but let's actually go through our calculations. How many people are in the park at time 9? 0 people. How many people are in the park at time this thing? Well, I need to plug in to my formula for h of t, that function defined by an integral. I need to do the integral from 9 to 15.794815 of e of t, or e of x, minus L of x dx. Same at 23. You need to go to the calculator right now. Calculate both of those. Give me an answer with decimals. I guess it's fine, even though if we're actually figuring out the number of people, we'd give a whole number. Tell me what your calculator gives you for h of 15.794815. Well, let's see. When I go to do my fn int of y1 minus y2 from 9 to 15.794815, I'm going to get about 3,950.680, meaning I can predict there are about 3,951 people in the park at that time. At time 23, go to the calculator, tell me what it gives you there. I know what it should be. Let's see. Oh, 1.014. There's one person left in the park at time 23. I'm really bored with reading answers, like number answers coming in Edpuzzle. Here's what I want. You're going to tell me why that one person's left in the park. Give me a good reason. Why is that person left in the park? I look forward to reading your answers tonight. You know how there's always like one person who just, gets lost, and I don't know. I look forward to seeing what you guys come up with. However, when do I have the most people in the park? My absolute maximum occurs at t equals 15.794815 hours. If I asked you how many people are in the park, then what is the absolute maximum number of people? 3,951. I realize it may seem a little silly to go through all this candidate's test work, since you probably know what's going to happen at that critical value rather than when it opens or when it closes, but this is required for your justification. And I'm going to show you another problem in a moment that requires this candidate's test. You're going to see a few of those in the homework. Okay, one problem down, 2 to go. Read number 10. Store the function in the calculator. And then stop. Before we do anything, make sure your calculator is in radian mode, or everything's going to be a little off here. Okay, so I know the starting amount. There's 500 tons initially. Here's the rate that gravel is arriving. Here's the rate that gravel is getting processed, so kind of like the rate that gravel is, forget about it. We'll deal with that later. First thing I want to deal with, finding g prime of 5, and then interpreting that. How about you do this? Go find g prime of 5 using nderiv on the calculator, and then see if you can tell me what this means. We looked at some problems like this yesterday. Give me the number and give me an explanation. Okay, I'm going to go use nderiv. Negative 24.588. Okay, this is the rate of change of the rate that gravel is arriving. I guess I could say the rate of change of the rate that gravel is arriving is this thing. But I think a better way to talk about it is, well, at t equals 5, make sure your explanation is referring to your time. That is important with these. The rate that unprocessed gravel is arriving is decreasing at a rate of 24.588 tons per hour squared. G of t was in tons per hour. The derivative will divide by our units of t, so tons per hour squared. It's the rate of change of the rate of change. Gravel is still showing up. The amount of gravel is increasing, but the rate that it's showing up is decreasing. This goes back to the whole COVID thing. Number of cases is increasing, but at a decreasing rate. Gravel is still increasing, but at a decreasing rate. Next, total amount of unprocessed gravel that has arrived during the hours of operation. I bet you can do part B. See if you can do part B. I'm just going to integrate the rate that gravel has arrived. I don't care about it getting processed or how much was there initially. I'm going to integrate that from 0 to 8. This will be an FN int problem. Looks like 825.551 tons. 825.551 tons of gravel. Now it gets a little involved. Is the amount of unprocessed gravel at the plant increasing or decreasing at time 5? Show the work that leads to your answer. Before I do this, I'd like to create a function for the amount of unprocessed gravel. I'm going to call this A of t. To do this, I'm going to take the amount I'm starting with. I'm going to add the amount of gravel that's arrived, and I'm going to subtract the amount of gravel that's been processed. I think this should look like start with 500. To that, I'm going to add the integral from 0 to t of what's the rate that gravel is arriving at this plant unprocessed? Say g of x. What's the rate that gravel is getting processed? Well, it's just that constant 100 tons per hour. That's a valid function. I'm going to say g of x minus 100. The rate that it's arriving. Integrate that, you get the total amount that's arrived. The rate that gravel is getting removed, integrate that, you get the total amount of gravel, maybe not getting removed, but total amount of gravel that's been processed. Okay, I want to know if this thing itself is increasing or decreasing. To do that, I need to look at its derivative. I need to look at a prime of t. Well, the derivative of 500 is 0. The derivative of my function defined by an integral is, well, the derivative and the integral cancel. I'm just going to plug in the t where the x is. I'm going to get g of t minus 100. I want to figure out, is the amount of unprocessed gravel increasing or decreasing at time 5? I think I'm going to plug in a 5. See if you can finish off this work and give me the answer with a justification. Okay, to do this, I'm going to do g of 5 minus 100. Negative 1.859, approximately. Well, since the derivative of the amount of unprocessed gravel is negative, it looks like the amount of unprocessed gravel is decreasing. Why? Because don't say a prime of t. Say a prime of 5. I mean, I guess you could say a prime of t at t equals 5, but that's more writing. I don't need to do that. I'm just going to say a prime of 5. is negative. One more. What is the maximum amount of unprocessed gravel at the plant during the hours of operation on the workday? Justify your answer. Well, I want to find the absolute maximum of that function I created of a of t. I might as well just rewrite this thing over here. First thing we need to do is find our critical values, which occur when the derivative equals 0, which means when g of t minus 100 equals 0. I'd like you to go solve that by graphing and send in what your critical value or values are. I am thinking about 4.923480 What we can do here, we can graph that function, and I can graph 100 and find where they intersect, or I could also graph the original function minus 100. That would also work. I kind of don't want to mess with that, though, because I may forget to change it back when I start doing some integrals. I'm going to set my window to between 0 and 8, count by ones. I have no clue what to go with here, so I don't know. Negative 300 to 300, count by 100. It's not bad. And where do they intersect? They're going to intersect, open on the screen. Oh, good. They're going to intersect at that 4.9234803. I'm again going to go use my candidates test. Make sure when you use the candidates test, you're labeling your columns. I've got time 0, one of my endpoints, 4.9234803, and time 8. At time 0, I know how much gravel is there. I was told there was 500 tons of gravel there. But for the other two, you need to plug into your function defined by an integral. You need to do 500 plus the integral from 0 to 4.9234803 of g of x minus 100 dx. And at time 8, you need to do 500 plus the integral from 0 to 8 of g of x minus 100 dx. What do you get when you plug in 4.9234803? I think the Fn int should have given you 635.376. How about when you plug in 8? 525.551. I don't think this was an obvious problem like the amusement park one, where I knew the maximum would have to be somewhere in the middle. It wouldn't be at the opening or at the close. I don't think it was a guarantee that like the starting amount wasn't the maximum or the ending amount wasn't the maximum or something like that. But I think our maximum does occur at that critical value in the middle. Now, I didn't ask you what time this happens. I asked you for what is the maximum amount of unprocessed gravel. Do not give me coordinates for these things. You've got to make sure you're answering within your context. So I'm going to say 635.376 tons of gravel. If I asked you when that's happening, that's when you'd give me the t-value. Do not give me coordinates. Pick out the number we care about, put units on it, and make sure you're reading the problem so you know if I want a time or if I want an amount. Okay. One more. Read number 11, please. Okay, so we've got to be able to do these calculus and context problems from formulas and stuff, but we also need to be able to work with them from tables of values, which is what's going on here. I think a few weeks ago I gave you a cumulative review where we reviewed how to do derivatives from tables of values. That's what we're going to deal with now. First of all, T is the time, W is the temperature of the water. I want to first estimate W prime of 12. Well, to estimate w prime of 12, I want to find basically the slope of the secant line that goes through these 2 points, and that'll be a pretty good approximation for the slope of the tangent line right at 12. I'm going to do w of 15 minus w of 9 over 15 minus 9. This looks like 67.9 minus 61.8 over 15 minus 9. Finish that off. Go to the calculator. Give me a decimal for that. What is w prime of 12? Thinking about 1.016 repeating. See if you can give me an interpretation. W of t is the temperature of the water. What does w prime of 12 mean? And make sure your explanation refers to the 12 and also put some units on things. W is the temperature, W prime is the rate of change of the temperature. At T equals 12, the temperature of the water is increasing. Oops, sorry, off the screen. Increasing at a rate of about 1.016 repeating degrees Fahrenheit per minute. You could say the temperature is changing at a rate of that, or since it was positive, we can say increasing at that rate. Part B. I want to figure out the integral from 0 to 20 of w prime of t dt, and then interpret what that means. Well, by my first fundamental theorem of calculus, if you integrate w prime, you're going to get just w of t from 0 to 20. Okay, well, that's going to be w of 20 minus w of 0. I think w of 20 is 71. I think w of 0 is 55. Subtract those, and you're going to get 16 degrees Fahrenheit. Well, what is this? I think this is just the change in the temperature. W prime is the rate of change in the temperature. You integrate that, you get the net change in temperature between time 0 and time 20. The explanation will need to refer to those times. Over t equals 0 to t equals 20, I'm going to say the temperature of the water increases by 16 degrees Fahrenheit, which I feel like should make a whole lot of sense. You found the temperature at time 20 minus the temperature at time 0. Sure, that's the rate of change, not the rate of change, that's the net change in your temperature. Next, read letter C. Let's not bother with the 1 over 20 for right now. Let's focus on just integrating from 0 to 20 w of t dt. When I'm done, I'll divide by the 1 over 20, and that's going to give me the average temperature. Well, we're asked to use a left Riemann sum to do this. I think I'm going to try to draw this thing out. I know at time 20, not 20, I don't know where that came from. At time 0, my temperature is 55. I know at time 4, my temperature is 57.1. I know at time 9, my temperature is 61.8. At time 15, it is 67.9. And at time 20, it is 71.0. I want a left endpoint sum, which means I'm going to draw in rectangles whose height is the height of the function at the left endpoint. I've got some function, I don't know, like that. But to draw in my rectangles, I'm going to have one look like that. The next look like this. And then that. And then that. The base of my first rectangle is 4. The height is the height at the left endpoint, so 4 times w of 0. I'll deal with that in a moment. The next one, my base is 5, My height is the height at the left endpoint, so between 4 and 9, my left endpoint is 4. Next, between 9 and 15, my base is 6. My height is the height at the left endpoint, 6 times w of 9, plus 5 times w of 15. Go to the table, pick out your values, and do this calculation using the calculator. And then we'll finish it off and deal with the average. But right now, just finish off this calculation and send that into Edpuzzle. So this is 4 times, my table tells me w of 0 is 55.0, plus 5 times 57.1, plus 6 times 61.8, plus 5 times 67.9. And go into the calculator. By the way, I think in the homework it's a non-calculator question. These can go either way on the AP exam. Do try the one in the homework without a calculator. The numbers are a little bit nicer. I'm getting about 1,215.8. That sort of has no meaning. This is like degrees Fahrenheit times minutes. That doesn't mean much. But I didn't care about that. I really wanted to find 1 over 20 times the integral from 0 to 20 of w of t dt. So that's going to be about 1,215.8 divided by 20. That is about 60.79 degrees Fahrenheit. That's my average temperature. Now, I want to know if this is an overestimate or an underestimate. It's been a long time since we've looked at those. I told you somewhere that my function w of t was strictly increasing. So this thing should really always be going up. Look at your drawing. Looking at this little picture over here, do those rectangles for that approximation look like an overestimate or an underestimate? Oh, I think that's an underestimate. I think there's a lot of area that I've undercounted. This is going to be an underestimate. And then we're asked to justify our answer. Why is this an underestimate? There are 2 pieces you need in your justification. Since w of t is increasing, and a left endpoint sum was used. This is in your AP review packet on the overestimate, underestimate page. This is nothing I would memorize. I would always draw out a picture. I've got something increasing. I'm using left endpoint sum. Oh, since I'm increasing and using a left endpoint sum, that is an underestimate. One more. Part D. I have the derivative of W. I have the rate of change of the temperature. I want to find the final temperature. Well, do you know your temperature at time 20? Sure you do. We've got that in the table. How about I take my temperature at time 20 and add to it the change in the temperature from time 20 to time 25. You write out the rest of the problem and do it. I'm just going to add in the integral from 20 to 25 of w of t dt. You're doing fn int on the calculator. 71 plus the integral of, oh, you know what? I never stored that function in the calculator. I'm just going to be lazy and type it in over here. As long as I'm good with parentheses, 0.060, wonderful. Close that. I think that's fine. X 20, 25. 73.043 degrees Celsius. No. Wow. Sorry. It's late. I'm tired. My classroom's still hot. They haven't yet fixed the temperature in here. 73.043 degrees Fahrenheit. Your homework is 4 AP free response questions. We have seen pretty much all the ideas you will need throughout these problems here. You'll definitely have to do some absolute max, absolute min stuff. You will absolutely see one, if not more than one of these on the AP exam come May. And I think that's about all I have to say about this stuff for now. Try these, and we will talk in class when I next see you.